Welcome back to Advent of Code. Today we're working on day 19. I just want to take a second to say thank you so much for the support in this series. It's super helpful. It's really pushing me to continue to the end of this Advent of Code challenge. And also don't forget to drop a like. Thanks. So today we're working on day 19 and we have some rules. The rules is a number and then you have a list of numbers or a letter or several numbers split with a pipe. And then we have a bunch of rules and then we have a bunch of strings and we need to check if the strings are matched by the rule 0. So that's the challenge. I see several ways to do that, and one way that is a bit, I would say that's the simplest one, would be to take the rule 0 and to generate all possible strings from that. The danger with that is that there could be so many possible strings, because here we have just a few rules. But you see that already with like these simple rules, it could match a lot of strings. Okay, here maybe, yeah, it could match all of these strings. So each time you add a rule, it can like really get crazy. And if you check the puzzle input, you see that there's a lot of pipe characters, which means that there are going to be so many possible strings. So we are going to drop this idea, which is to generate all possible strings. Instead, what I would like to try to do is to generate regular expressions from the rules. So I'm not sure this is going to work, but you know, this is worth trying. And right away we put the input test here, we split on double line return, which is here, and then we get lines of 0, these are const the rules. We can split again on the line return, this gives us one rule per line, and then const strings, we have lines 1, and here we can split again on line return. That's what we're gonna do. So what we want to do, we want to create one regular expression from the rules. So we're gonna have something that is parsing the rules. So I think actually here, you know what, we're gonna extract this into the 0, the key and the value here. I think that's gonna be helpful already. So we're gonna map rule, we're gonna create a regular expression that is a number at the beginning, then this, and then here many things, and we want to capture this as well. And you know that usually I like to name my capturing groups in regular expressions. So here this is going to be key, and here this is going to be the value, key value. I think that's an okay name. I like to also make sure we check what is the beginning and the end. Oh, for a second I'm doubting what is the end and the beginning for a regular expression. Okay, so the little thingy here is at the beginning and the $sign it's at the end of a regular expression. I don't know why I was doubting for a second, but this is good. So now we can use exec on the rule here, const groups is equal to that, then we can return groups right away. I think that is good. And when we do some parsing, I like to just do a little console log just to make sure we go slowly and steadily. And we have something that is correct as expected. So now we're gonna have to parse the rule into a regular expression. So we're gonna say const a function rule to regexp, and there's gonna be here actually here we're going to create an object, rules, actually we're going to create an object rule to regexp, and we're going to here say fill compute rules. And the reason is that we want to store each rule as soon as we compute it. Because, for example, what I'm meaning is that rule 0 is going to need the computing for the rule 4, but actually rule 2 is also going to need several times to compute the rule 4. So what we're going to do is we're going to store, we're going to use memoization here in this object, so that to make sure everything is stored here and we don't recompute several times a rule. So compute rules, here we're going to have a rule and rule and rules. Let's do that. And we're going to say if rule to regexp of, no, let's say rule in rule to regexp. In that case, we return this. So this is the memoization here, memoization part. If this is already in this cache, then we return the cached value. Otherwise, we're gonna have to compute to pass this value here. So first of all, value is equal to rules of rule. Is that it? Yeah, I think I don't know if they are in increasing order always. Let's just check here. No, okay. So here we don't start at 0. We start in the random order. So we're gonna have to be careful about that. So here, instead of that, what I want to do here, the rules, I want to create an object, and here we're gonna say for each. And what I'm gonna do, I'm gonna say rules of groups.key is equal groups.value. So what I'm creating here is an object that contains as the ID the key of the rule and as the value of the rule itself. That's going to be a bit helpful here, because here we're going to say rule key, and now we can do here compute rules of 0 and actually, yeah, let's do that. 0 and the rules. That looks good. So here we start with 0 in this function. Compute rules. The rule key is 0, and we're going to be using. We're going to be using it here, here, and here. And now we have the value and we need to pass this value. We're going to check if the value, if we're checking if the value is a full string only. So what I like to do is something like that, and here we're going to say whatever. This is just whatever. It could be whatever several times. In that case, we know that this is a proper string. So we're going to say let result equal value, and here we're just going to be replacing all of these double quotes by nothing. So what happens is if we have a rule that is like that, we check that this is exactly this, and we store just the A. And here I've replaced that so that if there are several characters, if this is like AA or ABC, this still works. Okay, now we need to check. We have several cases, by the way. I didn't enumerate all the cases. One is like that, and the other has the pipe. Actually, I'm not sure. I think we don't care about the pipe. Yeah, let's check if there is a pipe. A pipe is a special regex character, so we need to escape it. and we test if there is a pipe in the value. In that case, we need to there are several options, and we need to split value with space pipe space, so that we get an array with this value and this value. That's what we're gonna get here. So then we can say result. Result is gonna be, we're gonna put the result inside a parenthesis, and we need here to do, oh damn, so here instead of an ID of a rule key, I think I want to have this full thingy, because here I want to compute 2, 3. So here, instead of having the key, I want to have the value directly of the rule. So let's use that. So here we already have the value here. And now what we can do, oh wait, let me just change here also. We want the rules of 0 here. What happens is that we can reuse the compute rules here with options of 0. We can put a pipe and do the same with option of 1. I don't know if that is super clear, but I will try to explain that for a second. So actually we know that there is always just one pipe in the rules. That's the full example. So we're covering just this case. So option is going to be always option 0 and option 1. And what we're going to create, because we're creating a regular expression, here we have the starting parenthesis, the ending parenthesis, and here we have or, meaning this regular expression is going to match either this string or this string. So this is exactly what we wanted. So we're good in that case. And otherwise, we're just going to be saying we want the result is compute rules of value. Now I think this is going to create a for loop, an infinite loop. First of all, here I made a mistake. I need to make sure there is the object rules. But I want to avoid to use a global object in here. Actually, I'm using this global object, but that's it. No more global objects. So here, in that case, we are in this specific case when we have a list of rule IDs. So what I want to do, I want to resolve this list of rule IDs. So we need to const keys, and we need to say value split, and we need to split with a space. So now instead of having this string, we have a 4, a 1, and a 5 in an array. So we just here, in order to get the result, we're going to need to do keys.map key, and here we are computing the rule for rules of key rules. So what happens is that we, instead of having 4 here, we're going to say compute rules of that. Instead of having, and then this is going to create an array of results, and we're going to be joining this we're going to be just joining this together, and that's going to be our result. And if, yeah, I think that's good. If one of these is like that, you know what? I think I don't want to dive too much. Let's finish to do that and then check the results. And here what's really important is to memorize. So we have a cache here, and so we're going to say this is equal to result, and only then we can return result. And the very important step here is to avoid to compute several times the same rule. As I was saying here, you have the rule 4, that is just A, and here you have the rule 4, that is A. If this is just one character, it's okay, but let's say the rule 4 was something very complex, it's good to have memorized that. So now, one thing I wanted to check. Yeah, there are always just 2 options, not 3. So yeah, I think the code here is a bit overkill with the map, but that's fine, you know. Let's check. Here we would need to check when we compute rules to get regexp of 0. No. Here this is not of rules of 0, because here the key on this object is the value. So that's how you do it. Now we have an issue, which is starting to be interesting. So here we have 5, and here there is 5. So 5 should be working. Cannot read property of undefined. So here I think we're gonna be logging rules here. Why not? Rule there is. Oh wait, here the rule is undefined, so maybe I made a mistake here. Compute rules. Is there one time when we're calling that with an empty object? Could that be the problem here? Nope. Interesting. Here we have an undefined, and this is not looking good. We don't want to have an undefined. So we're gonna check here. We're gonna be here logging value rules, just to try to understand a bit more what's happening. Okay, so here 5, 5 and undefined. How come? 5 undefined. What is this? There's 2 numbers. That's actually one thing that I like to do when this console log can be a bit weird. So it's good to put square brackets around it so that you get a JSON object instead. This is making things a bit clearer. So here the value is 5, 5. And the rules is undefined. So it means at some point we call the function compute rules with an undefined value. Okay, here, this is the problem. I just made a mistake in my parentheses. The rules should have been here. So I was calling compute rules and the rules was undefined. So that was the problem. Now we can hide this console log and compute that again. And here, as you can see, we get a nice regular expression. So that's very exciting. I think the problem is that with this input, the regular expression is going to be crazy long, but you know what? That's fine. Now what we need to do once we computed the rule is we need to check here number of messages that completely match rule 0. So here, this we need to so const main rule. It's gonna be like that. You know what? It's because we want to make sure we capture the full string. So here we want also to create a new regexp. And here we're going to be console log the main rule just to make sure there is no issue. And it looks like it is quite good. So now we want to just go through each string and checking if everything goes fine. How many messages completely match? So here we're going to go and check each strings here. Oh, let's rename that to messages. So we're gonna be doing messages that map. No, actually, let's do a sum. Let sum equal 0, and do a little for off. Message of messages. If message that tests reads if main rule that tests message, in that case we do sum plus plus, and here we just console log sum. What I like to do is we're gonna indent that correctly because we want to check. We have 2 messages that match completely. The correct answer is 2. So I guess we're doing good. We're gonna take the full input here. Let's go. Oof, this is huge. And here we have 230. This was very fast, and I think the speed is really, I wanted to show this part. The speed is really due to this part where we're doing a memoization, so we're caching the intermediate results, and we avoid to recompute again and again the rules. That's quite important. That's making the complexity a lot better. Let's try, and this is good. We're good. Let's go to part 2. I'm gonna read that quickly. Okay, so I think part 2 is gonna be challenging. Now we have a new input. We replace the rule 8 and 11 with the following. So we're gonna be doing that, That's gonna be quite challenging. So what are we gonna do is we're gonna start by doing things very calmly. And for that we need to change the rules here. Rules of 8 is equal to this relatively annoying rule that contains a loop. I think we're never gonna make it work with our current implementation. I just want to test, just to double check that we clearly have an infinite loop. So if I were to reuse the same solution, I would say rule those 2 things, and then I would need to recompute each rule. So for that, we need to say rule to regexp is equal. We reset the rule to regexp here, which is our cache, and then we recompute the rules here. And here, I believe we're never gonna be ending this. Maximum call stack exceeded. So we really have a problem with the way we're doing things now. And I believe now I need to think a bit more about that. Wait. So I think we can't. So there are 2 things we can't do. We can't pre-compute each possible strings because we know that there are loops. So there is an infinity of strings that match the current setup. Secondly, we can't be creating a regular expression because also there is an infinity of strings. Although this is interesting. Maybe with a regular expression we can create some kind of a loop here. Basically 8 contains 8 and 11 contains 11. This is, I'm not sure we can make a nested loop with a regular expression, so that's why I think we need to discard this option. And I think the other option that we're gonna need to do, somehow, we're gonna need to check, we're gonna need to go here and check. So it starts with 8 and then it is 11 here. Is that the rule 0 here as well? 8 and 11. Oof. And is there other 8s anywhere? So yeah, here one thing that's interesting is really to understand the input to make sure we're not making stupid things. So 8 is always at the top. That's very important. And 11, oh wait, let me make sure I didn't do any mistake here. 8 is only here. That is correct. And then 11 is only on rule 0. Actually, I haven't seen 11. Where is 11? Damn. 11 here. Where is the rule 0? Sorry, I'm taking a second here, but okay, here. So this is going to be a key, which is that 8 and 11 are both at the root of our tree. So what we are going to do, basically we need to check 8 and 11, what are there. We need to check, we need to have a regular expression for 42, 31, and yeah, 42 and 31. If we have a regular expression for these two, then we know, then we can not care about that and just do a special case for rule 8 and 11. So now, instead of having like a complete tree with a complete graph with loops and everything, we know that we need to be right for the rule 42, 31. We need to have regular expression for those two rules, and this is it. So that's going to simplify things a lot. We're going to code that right away. So here we need to compute rules for two things. One is 42 and the other is 31. So here we're going to have two rules. Rule 42. Oops. Rule 42 and rule 31. 42, 31. Now I'm going to just be logging those two just to make sure. Rule 42, rule 31. So we have correct regular expression for those two rules. That's a big step because now we just need to encode the behavior of 0 being 8, 11. We know this is always the case because it is here in the example and here in our test case. So I'm going to go ahead and just do that because it shouldn't change anything. And now basically we have to hard code these three rules. That's going to be interesting. I think I'm going to take a little bit of thinking. I'm going to think a little bit and I'll be back with a clearer explanation. Okay, I won't lie, I had a great meal and now I am back and I have a good idea on what we need to do. So first of all, we know that these are the exact rule and the only rules that are important. And then we have those two things that are important. First of all, let's take the rule 8. The rule 8 is basically you have either 42 or 42 plus 8. And if you take that, if you take this is just 42. If the first element is this one, then the next one is this one, then you have 42, 42. So basically, this is like having 42 several times, at least one time. That is rule 8. Rule 8 is group 42 at least one time. Then here, rule 11, you have the first one can be 42, 31, or it could be 32, 42, 11, 31, and 11 can be this one. So basically what you have here is that you have 42 between 1, you have n times basically. What do you do? Like that, I believe, in regular expression. So you have n times 42 and then n times 31. This is the rule 11. So now that we've simplified our rule set here, that's going to be a lot simpler to do this correctly. So what we need to do is we need to check using these. So actually we can remove this because we want to match the rule anywhere in the string. Actually, we want to make sure this happens several times. So what we're going to do, we're going to say like that, plus this should happen at least one time, at least 2 times to be honest. And here we need to make sure these ones, this rule 31 happens in the end and at least one time as well. Actually, we can combine those two. So now we're going to combine that rule. So that's going to be it. We're going to make sure we have several times the rule 42 and then several times the rule 31. But that's not going to be enough, because we need to make sure we have n plus 1, at least n plus 1 here, and here n times. That's really going to be the next thing we need to check, because when we merge 8 and 11, you have 42 at least once, and then 42 n times and 31 n times. So what I'd like to do is to first of all check. We're going to go through each of the string. So here we're going to do something similar like that. And really doing this simplification is really going to help us a ton. So we need to check if rule test message, then here we need to make more tests. We need to count how many times we have rule 42. So I think we're gonna start by the, oh, I'm not sure. I'm not sure. So we need this rule. No. Here this is message dot. So what would be great is to have some kind of a way to count this, but we can't do that. So I think what we need to do is to split the string between these rule 42. So if we want to split the string, we're gonna, call this group 42, and we call that, oh no, because this is repeating, so we're gonna need to take all of these group 42 that are repeating, and we're gonna call that now group 42, We're going to do the same here. I'm going to make a parenthesis around the repeating group so that we have all of the repeated groups, and we call that group 31. Now we can say const matches rule dot exec message, and here we say if matches. In that case we extract the groups equal matches. Yeah, and I think, you know what, we're gonna be displaying something here. Console log groups, because I'm not super clear how well this is gonna work. Here this is the full input, so as we are going to start doing some good test here, we're gonna take this here and we're gonna paste it in here. Let's try that and see approximately where we are. Let's go. I need to node day19.js. Okay, so here we see the group 42 and the group 31. So that looks something that works. I'm a bit anxious that I'm missing something, but you know what? We need to go to the end and hopefully we have something that works. So now that we have the groups, what I want to check is how many in groups 42, how many times we have this rule matching. So what we're going to say is we're going to say matches 42 is equal to groups, this dot matches. Let me double check on MDN this. Okay, this is perfect. Using string.match and with the G flag, all results matching the complete regular expression will be returned, but capturing groups will not. So I think this is exactly what we want. So here we need to use the message, no, groups dot 42 dot, wait, groups dot group 42 dot match, and here we have to use the regular expression, but this is not a regular expression, so we have to do new regexp, and here we have to use the flag G. And we're going to do something similar for the group 31. 31. And now we can log here the matches 31 and matches 42, just for more deeper understanding. Actually, what I care here is just the length. I don't care about the individual matches. I care about the full length here. And now we have something really good, because we can check that there is at least the same number of group 42 than group 31, and this will match everything. So we need to check here if matches 42 is strictly above matches 31. And the reason is that here this is we need to have exactly the same number of 42 than 31 plus this one, so we know that we need at least one match 42 then match 31, and in that case we can do sum plus plus, and now we have 12. Let's check this out. The result is 12. So really here what I'm really enjoying is that we went slowly through each step, and we built on top of our solution that constructs a regular expression. And now, using the full data set, it finishes quite quickly. And let's see if this is the correct answer. Yes, this is the correct answer. So thank you very much for following. Thank you again for all the support in this series. It helps a ton. So don't forget to drop a like, a little comment, subscribe, and see you in the next one. Bye bye.